I thank the organizers for giving me an opportunity to interact with you on this occasion when you are undergoing training. Being from engineering background, you are also learning teaching learning methodologies. Today I am going to speak regarding activity-based learning. Is my slide visible?
Yes, sir, it's visible. Please.
My first interaction starts with a question to you. I want to know, do you conduct any activity while teaching? If yes, just scan this QR code from your camera, mobile camera, and give one response at a time. This will also register your presence. Keep your camera on this QR code. It will ask you what to do. Give the instruction to open, and then you can just give your response. Maybe older version of mobiles may not have this option. Is it visible and available to you?
Yes, sir, we have reached, at least I have reached to this. Do you conduct any activity while teaching? Yes.
Okay. I am waiting for responses. Do you conduct any activity while teaching? List one at a time. अगर आप एक्टिविटी करते हैं तो एक एक्टिविटी बताएं. जिनको अगर नहीं मिल रहा है तो मैंने लिंक चैट बॉक्स में शेयर किया है. आप उस पर क्लिक करके अपना रिस्पॉन्स दे सकते हैं. यस, somebody has said yes. क्लासरूम लेक्चर्स आपके कैसे रहते हैं, वही जानना चाह रहा हूँ मैं. अगर कुछ एक्टिविटी करते हैं तो उसको जानना चाह रहा हूँ. कोई यस कह रहा है, कोई प्रैक्टिकल कह रहा है, कोई ग्रुप में वे मेथड या कोई डेमोन्स्ट्रेशन कह रहा है. तो ये मुख्तलिफ किस्म के एक्टिविटीज़ हैं विच यू डू इन द क्लासरूम. टेकिंग यू इनपुट्स फ्रॉम दिस, somebody is doing quizzes and many activities are emerging. Let us go to the next. Okay, right. So I think in real time it is visible to you also what type of activities your colleagues are doing in the classroom while teaching. Okay, let us go to next slide. Yeah, I was talking about activity-based learning. By activity, we mean in the traditional classroom, the teacher speaks and the student listens to the teacher. Instead of that, we can have some activities in the classroom, like active and hands-on engagement of the students in the learning process can be made, where student does not sit idly listening to the teacher in a passive mode. He himself gets involved either by during the demonstration or in the laboratory work or any type of activity. Physical as well as mental involvement of the student will be there. Variety of activities to facilitate learning, comprehension and skill development. Learning may involve cognitive aspect, cognitive activity should be there. Comprehension also requires understanding, so it requires mind to work. Skill may require mind and hand coordination, so activity based learning becomes important. Activities make the learning process student centered. So student will be at the center of attention instead of teacher being at the center of stage. Promotion of critical thinking and problem solving skills will happen. Development of deeper understanding of concepts take place. Let me take you to the slide. In the next slide, I have given another question which I want to know from you. I do understand that you are from different engineering backgrounds and attending. I want to know which stream of engineering do you belong to? Can you just help me by guiding which stream you belong to, like computer education, civil, or mechanical, or any other? Please scan the QR code and give your inputs. Somebody says he or she is from civil. Any other opinion? Somebody says he is from mechanical engineering. Just give one word answer because it is taking two words as two different responses. Mechanical engineering teachers are there, civil engineering teachers are there. Anybody else from different background?
From computer engineering.
Okay. Computer engineering also teachers are there. So let us go to the next slide. I have taken few examples from your fields so that you can understand where activity-based learning takes place. This is an example from electrical and electronic engineering. Students build and testing circuits in a lab. First example. Second example, you can see that students are working on a team to build and program a robot. Means students are working and more than one student is also involved. Students using software to design and stimulate electrical systems. This is the third picture. Let me take you to some examples from mechanical engineering. Here you can see students are using computer assisted design software to design a machine part. Here students are operating on a CNC machine to manufacture a machine part. Students are testing the performance of a machine or engine. Next, I am taking example from civil engineering. In civil engineering, have a look at this picture. Here, students are conducting a site survey for construction of project. Most of the students are involved. They help each other to understand different concepts and the scientific principles behind construction of the bridge. Here, students using software to design, build a building or a bridge. You see different kinds of bridges are there. They are they are trying to create some software so that theoretical aspects can be completed. Practically, students of civil branch, students building a model bridge or structure to test the strength and stability. See, they have constructed a bridge, they are passing some weight and the weight increases, then the building collapses. So a model has been built to test what is theory and what is the practical output. Similarly, in computer science and engineering, activity-based learning is very much important. You can see here that students are writing and testing codes to solve programming problems. Like if students are using software to develop a website or web-based application, they are using cloud-based storage, they are using figures, they are using various written material, they are coding it, and they are designing a web-based application using this in a project mode. Here in this figure, I have shown students are working on a team to design and implement a software solution for a real-world problem. Real-world problems can be solved if you sit together in a group and try to understand each other's point of view and resolve the issues. When you want to conduct activity-based learning, you want to inculcate activity in your classroom teaching and learning, then you have to depend on theoretical perspectives. अगर थेरी या नज़रिया सही है तो उसका प्रैक्टिकल इम्प्लीकेशन भी दुरुस्त रहेगा. What are the theoretical perspectives behind having activity-based learning? First is constructivism. Constructivism says the knowledge is actively constructed by the learner rather than passively pursued from the instructor. If I keep on telling you or bombarding with the knowledge, you may listen, may hear, may understand or may not. But if you have some previous knowledge and based on that knowledge, if you try to listen to new content, you may be able to grasp much better. So previous knowledge is very much important. Prior knowledge and experiences play an important role in learning. Learners are motivated to learn when they are engaged in meaningful and authentic activities. Whatever you don't understand, if you are presented with, then it becomes like bhais ke aage been bajana. Means you do not have any knowledge of music and you are being presented with a beautiful music. You may not understand and relish it. So previous knowledge is very much important. Experimental learning. Learning is best achieved through direct experiences. That is why it is said that be Roman in Rome. आपको जो सीखना है उसमें घुल मिल जाइए ताकि आप सीखना आपका आसान हो. Learning is best achieved through direct experiences. You go to the field. The learning process is cyclical, involving 4 stages: concrete experience, reflection, observation, abstract conceptualization, and active experimentation. This is one aspect of theoretical perspective. Second is activities have to be done to resolve the problem-based learning. Learning begins with a problem or challenge that is meaningful to learners. Archimedes wanted to measure the weight of gold, purity of gold. He kept on thinking about it. He did not get any idea. Suddenly, when he was taking bath in a public hammam, some solution came to his mind, which is called as insightful learning. So problem has to be presented to the learner, then only the learning takes place. Learner works collaboratively to solve the problems using their prior knowledge and skills. Collaborative way of learning has to be adopted. The learning process is guided by the instructor who provides support and feedback. Here, the teacher is not giving the information, he is providing support and feedback. What is correct, what is not. But most of the effort is being done by himself. So it is a problem-based learning. Social learning theory. Man is a social animal. We look at various aspects around us and we learn many things. Learning occurs through observation and imitation of others. If somebody is operating in a laboratory, we look at him and try to improve upon his skills and we adopt best qualities and avoid the bad qualities. Learners are more likely to imitate behaviors that are rewarded to imitate behaviors that are punished. The social environment plays an important role in learning. Multi-intelligence theory. Nobody is an idiot. Everybody has got certain amount of intelligence, what we call as different kind of intelligence. Humans have 8 different intelligence. People who have joined today are having academic intelligence. And there are people with different intelligence. Like these 8 categories are listed as, linguistic intelligence, logical mathematical intelligence, spatial intelligence, bodily kinetic intelligence, musical intelligence, interpersonal intelligence, intrapersonal intelligence, naturalist intelligence. Like politicians have got interpersonal intelligence. They can manage the people very well. Then good speakers have got linguistic intelligence. Bank cashier may have logical mathematical intelligence. We have got different kind of intelligence, and all the children or our students also possess different kind of intelligence. That is why we have to provide them opportunity to work in team, so that their expertise can be collaborated and the problem can be resolved. And all intelligences are important and should be developed. Learners learn best when they are engaged in activities that appeal to their strengths and intelligence. So the situation should be created so that it should appeal to the learner. They should try to understand that it is important for me to learn. That provision should be made. Cognitive load theory. Like each human mind can have information of various load. Humans are limited. Humans have a limited amount of working memory. जैसे रैम होता है, रैंडम एक्सेस मेमोरी, पूरी की पूरी आप कंप्यूटर की मेमोरी रैम पे नहीं डालेंगे. Humans have a limited amount of working memory, which is the cognitive capacity used to process and manipulate information. Cognitive overload occurs when the amount of information presented to learner exceeds their working memory. Same case is with computer. You cannot overload your RAM. You have to give according to its capacity. Cognitive load theory provides guidance on how to design instructional material and activities to reduce cognitive overload and promote learning. Whatever information, like library rack, book rack, if you have 1,000 books, you will try to adjust and keep all books in different racks inside in the cupboard. So all the information have to be arranged systematically, so that additional information also can be kept. One information should be logically connected to another information. We should not burden the student with heavy information, but give the necessary information. Self-determination theory. There is a saying that you can take horse to water, but you cannot make horse to drink water. That means self-determination is very much important. People are motivated to engage in activities that they perceive as autonomous, competent, and related to others. The way you are sitting in this classroom, you are sitting passively. But when you go to your classroom, you become more active, because there is a self-determination that you have to teach your students. Self-determined determined motivation leads to better learning outcomes than externally motivated behavior. If you put the child in the classroom and pressurize him to learn, then he won't learn. Unless and until he is self-motivated. Zone of proximal development. The zone of proximal development is the range of tasks that learner can complete with assistance from a more knowledgeable others. Like you are lifting the person from lower floor to upper floor. Each other's help is required. Learning occurs most effectively when learners are working within their zone of proximal development. Active learning. As I am discussing about activity-based learning, active learning is also an important part. Active learning is a learning approach that emphasizes learner engagement and participation. Learners' engagement and participation are important. Without learner and without his participation, learning cannot take place. Active learning activities require learners to do more than passively receive information. जैसे टीचर चुस्त तालिब इल्म सुस्त हो तो कोई तालीम नहीं आकर होगी। तालीम वकूफ़ पज़ीर होने के लिए दोनों का भी चुस्त होना ज़रूरी है। बहरहाल तालिब इल्म का चुस्त होना बहुत ज़रूरी है। एक्टिव लर्निंग हैज़ बीन शोन to be more effective than passive learning in promoting long-term retention and understanding. Whatever has happened to you when you were active, that you remember for long duration. Bloom's taxonomy, in the previous session also you are discussing about Bloom's taxonomy. I have kept this theoretical perspective at the end of my discussion on different theories, Bloom's taxonomy. But I am going to elaborate it further when we go to the next slides. Bloom's taxonomy is a classification of learning objectives. किसी भी काम को करने का एक मकसद होता है। ऐसे मकासद के को साथ लेकर टीचर क्लासरूम में जाता है। अगर मकसद न हो तो जाना था जापान, पहुंच गए चीन। You wanted to reach a particular destination, but you get astray and go to a different place altogether. So objectives are very much important. Bloom's taxonomy gives us a classification, a taxonomy of learning objectives. They give 3 different domains. One is cognitive domain, second is affective domain, third is psychomotor domain. 3 domains are there. The cognitive domain is further subdivided into 6 levels. I am going to put more emphasis on this cognitive domain, which is divided into 6 levels. The basic level is knowledge, then comprehension, application, analysis, synthesis, and evaluation. This has been modified. I am going to take it further. Before I go to that cognitive domain, I just want to tell you there are benefits of having activity-based learning. अगर बच्चा खुद काम करके सीखे तो उसको अहमियत होगी। जैसे वालिदैन कमाते हैं, बच्चा खाता है, तो पैसों की अहमियत बच्चे को नहीं रहती। अगर वही बच्चा बड़ा होकर जब कमाने लगता है तो उसको हर पेनी की, हर रुपये की कीमत उसको समझ में आने लगती है। तो एक्टिविटी बेस्ड लर्निंग इसी तरह से है कि बच्चा खुद मेहनत करेगा तो हर उसके नॉलेज के हर गेन को वो की अहमियत समझेगा। He can have improved retention. Retention will be for longer duration. Whatever formula a plus b whole square is equal to a square plus b square plus, he will retain for longer duration. Enhanced comprehension. He will understand what the significance of the formula, significance of various diagrams, significance of machines, simple machine, the other machines. He can have critical thinking and he can think why this is like this, why it is not like this, what happens if sun suddenly disappears. Higher order thinking, he starts thinking in that situation how he is going to tackle, how the world is going to be. Conceptual mastery will be there. All the concepts will be clear to him if he puts effort. And since he is doing the activity, there will be an increased engagement. Skill also gets developed. He thinks about his thoughts, metacognition. Collaboration and communication skill happens because he works in the group. Reduced cognitive load. Since he is placing all the information like books in a rack systematically, he has got space for uploading some more information. Cognitive load can be reduced, long time retention will be there. Then while going through this, suddenly I have thought that I should ask your presence, can you classify your thoughts? क्या आप अपने ख्यालात को क्लासिफाई कर सकते हैं? अगर कर सकते हैं तो आप अपना जवाब QR कोड को स्कैन करके दें. यस, आस्किंग इज रॉन्ग बिकॉज एक बंदा भी यस बोलता है तो 100% बताएगा, दो भी बोल रहे हैं तो 100% यस बताएगा, कुछ नो बोले तो आप 25% नो, 75% यस, यानी 4 लोगों ने जवाब दिया. यानी देखिए, थॉट्स को हम क्लासीफाई कर सकते हैं. मैं जब ये क्वेश्चन बना रहा था, सोच नहीं सकता था कि मैं इस तरह के भी सिचुएशन आएगा कि मुझे सोचना पड़ेगा कि आप लोग सोच रहे हैं कि नहीं. तो देर इज पॉसिबिलिटी. सो लेट अस गो टू द नेक्स्ट. योर प्रेजेंस इज रजिस्टर्ड. थैंक यू. Okay. I am trying to go to next slide, but still answers are pouring in. Yeah. Again, one more thought has come to my mind. Can thoughts have dichotomous classification? Yes or no? अगर 4 लोग भी यस बोलेंगे तो चारों का जवाब यस है तो 100% ही बताएगा. 5 बोलेंगे तो 5 का भी यस बताएगा. कोई जवाब है? नो का भी जवाब है. यानी सिर्फ 2 लोगों ने जवाब दिया है. इससे अभी मुझे पता चल रहा है कि कैन थॉट्स हैव डायकोटोमस क्लासिफिकेशन. थॉट्स को अच्छे थॉट्स, बुरे थॉट्स, हायर ऑर्डर थॉट्स, लोअर ऑर्डर थॉट्स, क्लासरूम के थॉट्स, बाहर के थॉट्स, डायकोटोमस किया जा सकता है क्या? मुझे लग रहा है कि कौन बनेगा करोड़पति के सवाल के जैसा है, कह रहे हैं. सो इट कैन बी. ओके, लेट अस गो नेक्स्ट. आई एम क्लिकिंग, इट इज नॉट गोइंग. आई एम ट्राइंग टू गो टू नेक्स्ट क्वेश्चन. Okay, see, so much it came so quickly. 70. Can thoughts be of lower order and higher order? Any other answer? Can thoughts be of lower order and higher order? 100% yes. क्या QR कोड का छोटा होने की वजह से आप जवाब नहीं दे पा रहे हैं? आप ज़बानी तौर पे भी जवाब दे सकते हैं, रिटन में भी, चैट्स में भी दे सकते हैं. नो इश्यू ऑल टुगेदर. Are you all following? Am I on the right track? Okay. Yes. Yes. Okay. Right. I have to confirm this because technology requires me to test my online presence also. My computer is not supporting, so I am doing lot of acrobatics to get connected with you. I have used additional voice capture and speaking to you. I have switched off my camera for your purpose. Okay, anyway, this shows me that you all are agreeing that there can be two categories also, lower order thoughts and higher order thoughts. I am trying to go to next, this one slide. Sometimes it is not going very quickly. I don't know.
QR code is not scanning, sir.
It's okay. Okay.
That's why I'm writing on the message box. Yes, sir.
Yes, yes, yes. Thank you. Thank you for your cooperation and coordination. As I was telling you, I would like to take you to Bloom's taxonomy. Bloom's taxonomy, just now you heard in a previous lecture. It's a cognitive, it gives you an idea to know which level the student has understood your teaching. Like, for example, the basic level is to remember. Remember, if your student remembers, then he can recall or recognize information or ideas. जैसे बच्चे को सवाल पूछा जाए, लिस्ट 7 कॉन्टिनेंट्स, लिस्ट 7 कॉन्टिनेंट्स, तो जहन में है उसके सारे कॉन्टिनेंट्स और एक के बाद दिख रहे वो बताएगा. सो जस्ट ही हैज़ टू रिमेंबर, रिकॉल. Given a motorbike and a car, if you ask which is car among the two, easily say this is the car. He can recognize. The higher order or higher level thinking is called understanding. Understanding gives you an idea that understand the main idea of material, heard, viewed, or read. Whatever he has heard, viewed, or read, he understands, interpret, or summarize the idea in own words. For example, if you ask a child, explain the water cycle in your own words, then he will start explaining what is the water cycle, how does the water gets evaporated, it becomes a cloud, it cools down, then showers, the rain happens, and again water is collected on the ground. So if he understands the process, then he will be able to summarize the entire process. Apply. Apply is nothing but provide opportunity to use ideas, theories, or problem solving techniques and apply them to new situation. This is what, suppose if he is good at cooking, and if you ask him, write a recipe for your favorite dish, then he can apply his mind, write and provide a recipe. Analyze. Analyze means examine concepts or ideas to break them down into basic parts. Like, if a bicycle is there, he analyzes all the parts and tells you which part can be fit at which place, what is the relation between front wheel, back wheel, pedal, handle, etc. Identify different factors that contribute to climate change. If you ask, identify the different factors that contribute to climate change. We all say climate change is happening, but why it is happening, what are the different factors, he will identify and list if he has understood the information at that particular level. Evaluate is the next highest level of thinking, which helps the child to learn at higher level. Use standards and criteria to support opinions and views. Like, as a teacher, we try to support activity-based learning using Bloom's taxonomy. That Bloom's taxonomy also asks you to provide activities. So we are also using this while discussing with you. Evaluate the pros and cons of energy sources. Hydel power, then there is nuclear power, solar power. So he can use that standards and criteria to support his opinion, which is better, which is not, what are the pros and what are the cons for different energy types. Lastly, create is the level of thinking. We have started from remember, which is common to all. Everybody remembers many things. Few people understand something. Few people apply that knowledge in day-to-day life, And when we go to creation level, very few create the new things. Edison has created electricity. Graham Bell has created telephone. Marconi has created radio. So that is highest level of understanding of a concept. Assemble parts of knowledge into whole using creative thinking and problem solving. Here at PhD level also you see that students write their thesis, write their papers, create a short story, they create their own things. This is what is the highest level. When I was asking you different questions, I asked you whether there can be two different types of thinking orders, lower thinking orders, lower thinking skills and higher thinking skills. Most of you said yes. Yes, I do agree that there are two different kinds of thinking. Basically, most of us are using in the classroom these kind of thinkings, remembering, understanding, applying, where recall of the existing knowledge is there, grasping meaning of the instructional given in instructional material which you give, use the information in new but similar situation, not very innovative situation, new but similar situation. These are called lower order thinking skills. And when we look at the higher order thinking skills, analyze, take apart the known and identify the relationship, evaluating, examine information and make judgments, creating, use information to create new something new. These are the things which are taking place. I got some inbuilt activity also while going through this. There was a person called Edgar Dale. He has given a cone of experience. Cone of experience, what I am talking about is activity based learning. The more experience or exposure is given to the students, the more he learns. See, this is a cone of experience, top to bottom. Which part of the cone occupies a smaller area, which occupies the larger area? This area is more or this area is more? Which area is more? Are there any chats, answers? Okay. You are engineering teachers. I expect that most of you may be familiar that this area is smaller. Lower area is larger. Area wise I am talking. That means here the understanding or the things which are kept in mind by the students are less. Here things whatever is being taught by this method he will retain for longer duration. That means abstract things you teach, the understanding will be less, retention will be less. If you teach through concrete, this is the degree of abstraction. If you teach the material using concrete things, then he will retain for longer duration. What are abstract things? Text or verbal symbols. Just listen to an audio which I am playing now. Could you hear the audio? I think some responses are required for me to proceed. Not clear. If I ask somebody to reproduce what I played, can you reproduce? Can you reproduce that? No. Okay. That means this was a verbal symbol which you cannot reproduce. Can you close your eyes and reproduce this? I am just highlighting on the screen. Can you close your eyes and reproduce this? May not be. So these are abstract things. The language which I play before you, the script which I am showing may not be clear to you, and especially those who are coming from North India may not be able to write it. This is abstract. Abstract, the more abstract the things are, the lower the retention, the lower the understanding. So this information will not be of use. Similarly, you see this pictures. Whether you are part of North India or part of the South India, East or West, you will be able to make it, understand this, because these symbols, visual symbols, are clear. Go right, go left, take a U-turn, take a U-turn on the left. So these are road symbols which I have given here, and you can understand. Audio recordings, your photos are much better than these symbols or the text which was given to you. Motion pictures you can remember for longer duration. Exhibits which you see, like I was seeing a video on WhatsApp, wherein during the Ganesh festival, if the devotee touches the feet of Ganesha, it stands up and gives Ashirwad. That means this exhibit is very much active, so this will be remembered for longer duration. Field trips, if you want to show Heidel project, take your students to the project venue, then they will remember for longer duration. If acid based titration, if you want to show, demonstrate it in presence of students, they will understand it. Similarly, dramatized experiences, contrived experiences, direct purposeful experiences are more valuable in the classroom when you are providing activity-based learning. I am playing a small video. Just have a look of this. Okay, could you see that video? I have kept it very small. The only thing is, lemon was put in water glass. First of all, it touched the surface. When salt was put, it became more concentrated. Lemon did not touch the surface, but it started floating. So here, demonstration was given. Compared to these kind of learning is more concrete, so students can remember it for longer duration. Continuing with Edgar Dale's cone of experience, I would like to tell you that there is a famous Confucius saying, I see and I forget, I hear and I remember, I do and I understand. So which is better among the three? Hearing, seeing and doing? Yes, doing is much more important. So activity based learning has to be done in the classroom. There was an experiment done. I've taken this slide from the website. After 2 weeks, they have tried to know how much the students remember. After reading 10% of what they have read, they remembered. Hearing words, when you talk to each other, probably you remember more than what you have read. If you see an accident or a situation, then 30% of what you see you remember, which is more than the reading and hearing. Watching a movie, looking at an exhibit, watching a demonstration, seeing it done on location. 50% of what we see and hear. Here, demonstration is giving you more concentrated information. Participating in a discussion or giving a talk, like what I am speaking now, 70% of what we say we remember after 2 weeks, 30% is still lost. Doing a dramatic presentation, simulating the real experience, doing the real thing, that will help you to remember 90% of what we say and do. That means when you look at this cone, you see that instead of giving them only reading in the classroom, give them opportunity for simulation, drama, or experimenting in the real laboratory. They will remember for duration. Types of activities which you can provide are experiential learning, problem-based learning, hands-on learning, interactive simulations, group discussions, case studies, role playing, debates and presentations, collaborative projects, online quizzes and polls, peer teaching, critical reflection. These are the kind of activities through which you can provide more activities in the classroom. I was trying to look into challenges and their solutions while using activity based learning. I know it's 5 o'clock. Can I continue for a few more minutes, please? Organizers,
Yes, sir, you can.
many are leaving, so that gives me an impression that time.
Yes, sir.
Okay, few more minutes, please. Challenges and solutions while using activity-based learning. Faculty training and development is a challenge. Challenge because there is a resistance to change. We are good at taking lecture-based method classes because we have to complete the syllabus. Lack of experience, teachers do not have experience of activity-based learning. Time is another constant. So these are the challenges. For this, we can attain these things by professional development, mentoring, or giving incentives. Infrastructure and resource requirement is another challenge because we lack the resources. The resources required, heavy cost, logistic arrangements are difficult. So therefore, solutions are give as much resources as possible, share facilities of BTech program and diploma program. Online tools can be made available. Assessment and evaluation methods is another challenge because we follow traditional assessment model. Objective evaluation is not there. Therefore, alternative assessment strategies, rubrics and criteria-based peer assessment can be involved. Addressing student resistance, comfort with traditional methods, perceived difficulties, provide support, incremental implementation, feedback and reflection. These are the solutions. Two videos. See, case studies also I tried to look into. Indian Institute of Bombay is doing a Lavya program and using activity-based
Friends,
learning.
today I will show you a mechanical project known as pedal hacksaw. This project is prepared by our college team, and now I will show you the main components of this project, and then I will show you the operation of this project. Here are the components. First was this project. Okay. Now see what are the components used in this project. This is a cycle pedal and set with crank. Pipe vice. Now we have arranged position.
This is one, and another one video I'm just playing. Have a look of this. team building and cooperative exercises which can be adopted in the classroom by you all. There are future trends and innovations which are giving us challenges for activity-based learning, like emerging technologies, artificial intelligence, virtual reality, augmented reality, how they can be used in the learning, activity-based learning. Artificial intelligence, virtual reality and augmented reality. Personalized learning happens, assessment and feedback is easy, intelligent tutoring system and immersive simulation, field trips and labs are possible, visualization is possible by using these technologies. You can use gamification and learning analytics also, which will help you in engaging the students. Progress can be tracked, competition collaborations can be done, data driven insights can be taken, whosoever are leaving behind they can be taught better, then underachievers can be found out, earlier intervention can be done, continuous improvement can also be made. Tools, global trends in engineering education. Since most of you are, almost all of you are from engineering background, I would like to tell you that activity-based learning requires you to be more interdisciplinary. Learning has to be provided. Project-based learning has to be given, involving in transdisciplinary approach. Sustainable and ethical considerations have to be given. Global collaboration need to be there. Industry integration is need of the day. Digital transformation have to take place. And if you want to implement, finally, if you want to implement the activity-based learning, I suggest you to go step by step. First step is to begin integrating activity-based learning in your curriculum. Second step is develop some strategies for continuous improvement. Third is to identify resources and tools for faculty and students. Steps to begin integrating activity-based learning. Do the need assessment. Arrange the faculty training programs like you are doing now. Curriculum integration has to be done. Start in small groups and make it available to all. Clear the communication. Strategies for continuous improvement. Make arrangement for feedback mechanism. Data-driven decisions. You can change the methodology if different set of data arises. Faculty collaboration, like you are from engineering, I am from education, we are collaborating in today's training program. Similarly, projects can be collaborated. Professional development can be taken. Adaptation and flexibility has to be there. Resources and tools for faculty and students. Faculty resources have to be identified. Student support has to be provided, technology integration has to be done, community building, feedback mechanism is to be made available. This is all I wanted to discuss with you. I thank the organizers for giving me an opportunity to interact with you.